Okay, guys. So this is the grade 12 video on series and sequences, ne? Because I realized, or some of you actually asked for this topic, or you wanted a video on it, because I think by the time when we were discussing this topic, maybe you hadn't joined the lessons yet. So I decided, or let me make a video for you, for those who weren't able to attend when I was discussing this topic, and for those who want to revise as well, ne? So yeah. I believe or this will be very helpful for you guys. So I listen to your request. So let's look at the question. Game more question 4. The statement we have 1 minus x, okay, which is the first term, and then x plus 2 here, term number 2, then 2x minus 5 is the third term. So we can now three terms. So but these are the first three terms of an arithmetic sequence. So they're already telling us what this sequence is arithmetic. Remember, normally two forms of sequences, okay? It's either an arithmetic sequence or a geometric sequences. So those are the two sequences that we have. Okay, we also have another one here, quadratic sequence, but that one I really don't want to get into it today. Obviously today we are going to focus on the arithmetic because that's what the question is focusing on. So arithmetic sequence get the one with the common difference, but the geometric, you don't have a common difference. The geometric sequence, instead you're going to have a common ratio, ne? You're gonna be having a ratio instead of a difference. So the ratio is gonna be common. Then in terms of this one, in terms of the arithmetic one, the difference is the one that is common. Then the first question. Okay, guys. So for this one, I think, or we can just do 4.1 and 4.2. Already, these two questions are a mouthful. Then 4.3 is going to be very, very long. So this one is going to require maybe a video on its own. So I'm not going to be doing it today. This one is Sigma. You can see. So that one, this one, if I do it for you, then it will be in another video because it's also very, very long, so I can't do them everything here in the same video. Okay, so to determine the value of x, ne, we are gonna make use of the difference. They already told us that this is arithmetic, so we already know that there is a common difference. You understand? So when you calculate a common difference, you can just take term number 2 and subtract term number 1 and get term number 2, t2, subtract term number 1. That is the most common way to do it. Or if you don't want to use term 2 minus term number 1, maybe you can take term number 3 and subtract term number 2. So basically you just take you just choose any term and get, you just take that term and then you subtract the previous term. So if you choose term number 3, the previous term that you're going to be subtracting, it over term number 2. You understand what I'm saying? So even if you don't say term number 2 subtract term number 1, you can also say term number 3 subtract term number 2. The answer will still be the same because the difference is common. It's constant throughout the sequence. So whether you say term 3 minus term 2, or you say term 2 minus term 1, the difference will be the same, or no matter which terms you choose to utilize. You understand? So in this case, since t2 minus t1 is going to be the same as t3 minus t2 because both of them are differences and the difference is the same. You can just say t2 minus t1 and get, then what are equal to t3 minus t2. So t2 minus t1 is equal to t3 minus t2 because both of them, they provide us with the difference. It's common inside of the sequence. You understand? So both of them, they give us the same difference, so that's why we can equate them. And the reason why I'm equating them in the first place, guys, they are equal, yes, because they're going to give us the same difference. But the reason why I want to equate them in the first place is because I want to create an equation. Determine the value of x, and get, when you solve for x, you're going to be given an equation. You can't solve for x when you have just an expression. It has to be an equation. So they say determine the value of x. For us to find x, we need to actually have an equation. So that's why Sancheki created an equation, and I equate t2 minus t1 to t3 minus t2. So if it's an equation like this, it becomes easier. I can easily solve for x. So all I have to do right now is to substitute with the values t2, t1, t3. Okay, so let's start with t2. Our term number 2, get this one, get x plus 2. So in the place of t2, I write x plus 2. Then got minus t1 ke 1 minus x, so it's over minus 1 minus x. Then I put it in brackets like this, because we have a sign in front in front of the bracket. So that's why it's important I must put the bracket so that this sign can be distributed into both of the terms. So re tlo re equal to, so essentially times the negative sign. In other words, you must times the negative sign in front of the brackets by both of the terms they are inside of the brackets here. So that's why it's important to put the brackets. Then term number 3, renali 2x minus 5. So basically, really the brackets, I'm just putting them for every term because they've put them in brackets already. Everything is put in brackets in terms of the terms that we are given. So I just write them exactly as they are. So T3 ke 2x minus 5, then minus T2 again. T2 we said ke x plus 2. You can see it there. Term number 2. Then when it's like this, you just gonna simplify as much as you can. Okay, let me do this. So basically, like when you simplify here, you can start by saying x plus 2, right? And you write it down. Then we are going to now multiply the negative sign into the brackets where it is necessary. So for this one, the negative sign in front of the bracket, Sanjebe multiplied by both of the terms in the brackets because it's in front of the brackets, the terms are in. You understand? So we're gonna say negative times 1. It got for negative 1. And get negative times 1 is negative 1. Then we also say negative times negative x. This is not just x, guys, it's negative x. So make sure that you mind the sign when you are multiplying. So negative times negative x. And get so again negative times negative. So it's gonna give us positive because the negative signs are the same. And get when you are timesing the same sign, the answer is gonna be positive, even though the signs are negative, but because they are the same, then you're gonna get a positive answer. So negative times negative ke positive. It means that it's gonna be positive x. And get then equal to, then on this side, the first bracket we have 2x minus 5. Yeah, the first bracket, ne? The reason why I'm just writing them out of the brackets is because they don't have any number, any term, or any sign in front of the brackets. For example, 2x minus 5, there's nothing in front of the brackets. So I just remove the brackets. And even x plus 2 here is the same thing. The x plus 2 on the left, there's no sign or number in front of the brackets. So I just write it as it is. Then for this one, we have a negative sign. For the other x plus 2 on the right here, we have a negative sign in front, so we have to times now by the negative sign. So we say negative times x is going to give us a negative x. And then negative times 2 is going to give us a negative 2. And remember, the 2 is positive, so negative times positive, we obviously know what is going to give us a negative sign because the signs are different. So again, negative 2. Right. Okay, let's add like terms right now, guys. And we can start by saying x plus x equal to 2x. And x plus x equal 2x. So because each of the x's, they have 1 in front, because remember, if they don't write any coefficient, it means that the coefficient is 1. Just like exponent 1, we don't write it, but it's there if they didn't write any exponent. So more 1 plus 1 equal to 2. That's why we say it's 2x. So I'm just breaking down everything so that even someone is the first time seeing this, you can be able to know. Because I know you might need some revision from the previous grades, especially if maybe you're upgrading. So I just need to break down everything just to make sure everyone understands everything very, very well. Okay, so 2 minus 1, it will 1, so it will plus 1. Then equals to, then make it 2x minus x. 2x minus x, what is it gonna be? More minus x, don't forget the number, it's negative 1 in front. There's a 1 in front because they just wrote negative, they didn't write a number. So it means that the number should be 1. Remember. So 2 minus 1 2 minus 1 is 1. So, but I can't write 1x, I just write x. The 1 in front is not necessary for me to write. So I just write x, not 1x. Then here, negative 5 minus 2, even if you just put it on the calculator, you're going to get negative 7 there. Then now we have to group the like terms. For example, 2x, I'm going to write it on this side. Then it means what I'm going to have to bring this x and take it to the left so that it can become with 2x because they are like terms. So when I take it to this side, it means that I'm going to have to change the sign to a negative because remember, it's skipping the equal sign. So as soon as it skips the equal sign, its sign will change. So the x will become a negative x and it becomes the opposite sign. Then the 1, I'm going to bring it to the right hand side. On the right hand side, now it means we're left with the negative 7. So 1, when it comes to the other side, to the right here, it will become a negative 1. The sign will also change because it's skipping the equal sign as well. So it will be positive, from positive to negative 1. Okay, 2x minus x, we said we're gonna subtract the coefficients. So get 2 minus 1 here. Get 2 minus 1 is what? It's 1. So the answer is gonna be 1x. 1x is just x. Then equals to negative 7 minus 1 ki negative 8. So x is equal to negative 8. Simple. So basically here you just make use of the the formula that we use for difference. You see, so you can use t2, you take t2 minus t1, you equate it to t3 minus t2. That way you just like create an equation using difference. It's very simple. So as long as you can make use of the terms, ne? The reason why we are using the terms, term number 1, term number 2, and term number 3 is because these terms they consist of the x. So they are necessary for us to find x because the x is in the terms. You understand? So we have to use them. Then x is equal to 8. Done. Simple. Okay, then I said we're going to do 4.1 and 4.2. So let's check out 4.2. I'll just grab some of these. Okay. So 4.2 here, they say if the first three terms of this pattern get 9, negative 6, and negative 21. This is not a different pattern, guys, ne? Is the same pattern as the one that we are given from the statement above. The only difference, the pattern that we are given from the statement is not completely numerical values. It consists of variables. So ke mixture ya di-number le di-variable. So it's not just numerical values, but this one they gave us in the form of numerical values. For example, e re ke le bontsheng ka term number 1. Term number 1 ankere from the statement above ke 1 minus x. So you can say 1 minus, then in the place of x, remember we just calculated it now, we said ke negative 8. Ankere? So if you say this negative, you times it by the negative 8, obviously it's going to give you a positive 8. So it's about 1 plus 8. Then 1 plus 8 is what? Is 9. And that's what the first term is. So when I use term number 1, 1 minus x, and I substitute with the x, it gives me the first term for 4.2. So that's why I say this is the same sequence. It's just that they wrote it in numerical values. So yeah. So I'm just emphasizing these things to understand how the questions are connected. I don't know if you get my point. Okay. So they say this is the sequence, now this is the pattern. Then they say we need to calculate the numerical value of the sum of the first 300 terms, which is S100. When they say the sum, you are looking at Sn. Ne? Sn is the sum. And when you are dealing with Sn right now, then it means that we are dealing with series in a way. It's like in terms of Sn, we use it like mostly in terms of series. Here we have a pattern, but if they say we must look for the sum of the first 100 terms, so it's like it becomes now a series in a way because we are looking for the sum, meaning there's addition. You understand? So okay. To find the S100, ne, the sum of the first 100 terms, which is the S100, that is simple. It's not a difficult thing at all. Okay, let me just do this. Okay guys, so for you to actually be able to answer these questions, ne, you must know which formulas can you use. In terms of the Sn formula, the sum, we have two formulas that we can use for arithmetic. Remember, these are arithmetic sequences. You don't just use any sequence. You must make sure that the sequences are arithmetic. So we have two sequences that we can use. The first sequence, Sn, equals to a, oh sorry, not a, I mean n over 2, then in brackets a plus l. This is the first formula. We have two formulas for arithmetic series for the Sn formula, ne? So this is for the first one, ne? Okay. I'm gonna do this. I'm gonna write down the formulas, then I need to verify them just to make sure. But I use them all the time, so I already know them, but I just wanna make sure I don't make mistakes. So let's see. Okay, yeah, so yeah, I have the formulas here. So yeah, the first one I can see that it's already the correct formula. So just want to verify just to make sure that I always give you guys the correct information. So it's Sn. The second formula, this is formula 1, right? The second formula is n over 2, then in brackets 2a plus, then n minus 1, then d outside here, n minus 1 is in brackets again, then we close the bigger brackets. Okay guys, these are two formulas. So why do we need two formulas? Why don't we just have one? The reason is because you cannot just use any of the two formulas. You have to use a specific one. Why? How are they different? Okay, the first formula, ne, you use it if you know the last term of the sequence or of the series. So this one you use it if the last term is known. If you know what the last term is from your sequence or from your series, from whatever they've given you there, last term known. If you know what the last term is, then you use formula 1. But if you don't know, you're gonna be forced to use formula 2. So formula 2 is if the last term is not known. If you don't know what the last term is, then you're gonna use formula 2. So that's the difference. You cannot just use any of the two formulas. You can't just pick. You understand? You have to choose the most relevant one. So let's go back, guys. This is our here is our sequence: K9, -6, -21. So if you can look at the pattern here, they put 3 dots here to show that it's actually continuing. You understand? So it doesn't end go on -21. -21 is just the last term that they wrote, but it doesn't end there. They just wrote the first 3 terms, but it continues. There are more terms that come after the ones that they've written. But the only thing we can see here, they never indicated what is the last term gonna be, or if there's even gonna be a last term, or the pattern is gonna continue until I don't know. So this one, they didn't indicate any last term. We don't know where are they gonna stop with which term are they gonna stop with. You understand? So the last term, we don't have any knowledge of it anywhere. They didn't indicate it. You understand? So we don't know it. So since we don't know the last term, it means term number, what do you call it, the formula number 2 is the correct one to use. Okay, let me do it like this. So formula 2 being this one, right? So it's the one that we're going to be utilizing in this case, because that's the one that we use if the last term is not known. So we don't know it really. So it means I'm going to write Sn equals n over 2, then open brackets 2a plus, then n minus 1 here, then d, like this. So this is formula number 2. Okay, so we already know that we are supposed to calculate S100, right? The sum of the first 100 terms. That's what they said in the statement, which is S100. So in the place of n, it means that we're going to be having 100 here. So it's S100 equals to. So it means that everywhere in this formula where we see n, we're going to put 100. So because in the place of Sn there, in the statement, they told us what it's supposed to be. The one that we need to calculate is the S100. The first 100 terms, and get the sum of the first 100 terms. So it's S100. So in the place of n, we have 100. So everywhere we see n, we put 100. So we have n over 2 here. So it means we're 100 over 2, and get then open brackets 2a. Oh, okay, guys. Let me list some of the things that we need to know. We need to list what is a, what is d, what is n, because those are the things that we're going to be substituting. Understand? So let's start with a. A is not difficult. You don't even have to calculate in this case. A is just going to be equal to the first term. A always represents the first term. If you don't know it, then you'll know it from now. A is always the first term, term number 1. Whatever the first term is in the pattern, in the series, in the sequence, that is what A represents. So here we already know that our first term is 9. See, so it means that a is equal to what? To 9. That is the first term. And then we also need to know the d, right? What is d? D, remember, is the constant difference, and d, remember, we can just calculate it by taking term number 2 and subtracting term number 1. So let's go back. Term number 2 is -6, term number 1 is 9. So it means we're going to say -6 minus 9. So we take the second term, subtract the first term, and get -6 minus 9. So -6 minus 9, it will just give us a -15 there. So that is the difference. And then lastly, our n, we already said it's 100, because they say calculate S100, and 100 is in the place of n. Right. So in the place of a here, it means instead of 2a, I'm gonna write 2, then in brackets 9. So it's 2 times 9, right? Then plus n minus 1. So n is 100, so it's gonna be 100 minus 1, right? Then d is what? D, we already said, is -15 when we subtracted term number 1 from term number 2. Okay, then we substituted everything. Then someone can just decide that you're gonna put everything on the calculator the way it is, right? Then you get your answer. This one, the thing that I don't like by just putting it on the calculator is because it consists of a lot of things now. We have too many brackets, so my suggestion would be to simplify it first, né? When you simplify it first, maybe you won't have so many numbers inside, then you can put it on the calculator. Like when you have just simplified it just a little bit, you don't have to simplify it too much. It's just that for myself, I really love calculations, so I'm gonna be simplifying a lot. But my point is that don't start. You can put it on the calculator and get the correct answer. But when it has too much bracket like this, I just don't want people to make mistakes. Maybe you forgot a bracket somewhere. It's gonna be a problem. So that's why I just say, simplify it first. We can just start by saying 100 divided by 2 is going to be 50, right? Half of 100 is 50. Then in brackets, here we have 2 times 9, 9, 18. 2 times 9 is 18, right? And then plus, then we have brackets here. In the brackets, it's 100 minus 1, and 100 minus 1 is obviously 99. And get so Otoja 99, you just say 100 minus 1, you write 99. Then this 99, it must be multiplied by the difference, and get which is negative 15. So you subtract the 100 and the 1 first, then you get 99. Then the answer that you get, you are going to times it by the difference, by the 15 on the side there. All right. So you say 99 times negative 15. 99 times negative 15. When I put it on my calculator, I got negative 1485. Negative 1485. Right. So you can put it on the calculator like this. Now it's simplified, but I'll just go on further with you, ne? You just decide how to do it. S100 is equal to 50. Then our brackets here, we have 18. Then here we can times the positive into the brackets. So it's gonna be positive times negative, ne? Because we have a negative for the 1485. Positive times negative is negative since the signs are different. So you get negative 1485. Then you just simply say 18 minus 1485, which will give you 18 minus 1485. You can put it on the calculator, it will be negative 1467. Yeah, negative 1467. So when it's like this, then you put everything on the calculator. So negative 1467 times 50 will give us negative 73350. So it's negative 73,350. Then this is the answer. This is very simple, isn't it? You don't have to simplify it up until where I did. I really like simplified it to the last degree. So you just choose to simplify it to a certain level where it won't be too complicated to actually put it on the calculator. Then this is the answer. You're done. So basically, guys, 4.1, 4.2, just calculate like that. It's just a matter of applying the correct laws, using the correct formulas. It's not a difficult thing, even though maybe it might be long and take some time. But as long as you understand the formulas to use, how to substitute, how to actually simplify, which is simplifying is actually a grade 9 thing, guys. You learn how to simplify from grade 9, so it's not a problem. So basically, yeah, just work it out like that. Very easy, né? Okay, so I know that this video is gonna be very, very helpful for all of you guys, even those who didn't ask for the video. You can just watch it, and then and remember to when I send the video to you guys, you can just do a thumbs up to show that you've watched the video, or you're gonna be watching it, just to receive feedback from you guys, ne? Then yeah, basically this is all. Then I'll see you guys in the next lesson or the next video, whatever it will be. Okay, bye.